So in this video we're going to take a look at some of the properties of the imaginary number I. So we know that I is equal to the square root of -1, okay, by definition. So then I squared must equal the square root of -1 squared, which is just -1. I cubed is the same thing as I squared times I, which is the same thing as -1 times I. And I to the fourth is the same thing as I squared times I squared. Same thing as -1 times -1, so it's +1. So there I have this little pattern that I to the first power is just written as I squared is written as -1, I cubed is written as I to the fourth is written as +1. Then the pattern starts all over again. So I to the fifth is written as I to the sixth is written as -1, I to the seventh is written as I, etc. So it goes on and on and on. Okay? Now, due to that pattern, what we realize is that anytime I have an I with an exponent, I can actually rewrite it so that I have something that may or may not have an I in it with no exponent. So for example, if I have I to the 9th power, okay, I can rewrite that problem without an exponent. So looking up here, you could kind of continue, so you could say I to the 8th is then we're back to +1, I to the 9th we're back to I. You can definitely do that. Or what you could do is take your exponent, 9, and long divide by 4. 4 goes into 9 twice. We have a remainder of 1. Okay? I can ignore the number of times that 4 goes into 9 and just focus on my remainder. That's going to tell me with a repeated pattern that I'm right here, I to the first power. So I to the 9th is actually the same thing as I to the 42nd, similarly, 42 divided by 4. I'm always dividing by 4 because my pattern is 4 long. So 42 divided by 4 goes into the 4 once. So 4, 0, 0 goes into 2 rather, goes into 2 0 times. So that is a remainder of 2. So remainder of 2, remainder 1, remainder 2. So I to the 42nd power is -1. I to the 453rd power. Okay, so this can get ridiculous. 453 divided by 4, 1. Bring the 5 down 1 time. Okay, 3 times. Remainder of 1. So again, remainder 1 brings me back to I. So 4I to the 453rd power is equal to I. How about if I have 4I to the 24th power? Well, 24 is unique because it's divisible by 4. There is no remainder. Anytime there is no remainder, remainder 1, remainder 2, remainder 3, the last term of my pattern is no remainder. So this would be 4 times that last term, which is 1, which would be 4. Now, because of this property, okay, we can then sometimes multiply compound numbers, complex numbers rather. 2 minus 4i times 6 plus 3i. I'm going to FOIL it like normal. 12 plus 6i minus 24i minus 12i squared. Combine like terms. 12 minus 18i minus 12i squared, but I squared is just negative 1. So that's 12 minus 18i plus 12 is 24 minus 18i. Okay? So even in my expressions, I should never have an I with an exponent left in my final answer. So that multiplying two complex numbers gives me a new complex number.